it what's a mineral.
What's the first thing that you notice about your mineral?
It's solid.
It is solid. That's right. Lizzie, what else do you notice about your mineral?
It has crystals.
It does have crystals. Ben, do you know anything else about it?
Man-made.
It's not man-made. You're right.
And it's not living.
It isn't living. That's right.
I get it!
You get it? Do you know what a mineral is then?
Yeah, I think I know.
You think you know. So it's a solid.
Crystals?
It has crystals.
It is not man-made.
It's not man-made, and it's
not living.
Right, good job. So those are the 4 things that all minerals have. And did you know that minerals are like the ingredients that make up every rock that's out there? Did you know that?
Yes.
You did? So it's like making a cookie, right? You put all the minerals in, and you bake it, and what do you get in return?
Cookie.
Or a rock, right? So in order to be categorized as a mineral, there's actually 5 things that the mineral has to have. But my kids are a little too small to understand the one that we didn't talk about. So the first one is that it's naturally occurring, meaning it's not man-made. It has to be inorganic, which means it's not alive or made from things that were living. It has to be a solid, so no liquids or gases. We're going to skip number 4, but 5 is crystal structure, meaning it has an orderly arrangement of atoms. And go back to number 4 now. It has to have a definite chemical structure, meaning each mineral is always bonded together with the atoms in the same way. So my kids are a little too small to understand that, but think of it like molecules, and the molecules always get put together in the same way. So it's the building blocks, and the blocks always put together in the same way in that mineral. All minerals can be identified using the following different properties: hardness, color, streak, luster, density, crystal shape, cleavage, fracture, and different special properties the mineral may have. For hardness, we're going to look at a different scale called Mohs hardness scale, but basically it's mineral's resistance to being scratched. The color is not always going to be the best way to identify a mineral, because some minerals, depending on what other impurities they have, can change colors. For example, quartz comes in many different colors. You can find quartz that's pink, you can find quartz that's white or clear, we can find smoky colored or gray colored quartz. So that's not the best way to identify something like quartz. But there are a few minerals like sulfur, which has a bright yellow color. Streak is going to be the color of a mineral's powder on a streak plate. The luster is how the mineral reflects light on its surface. Does it look metallic or is it glassy looking? The density is the mass divided by its volume. You learned about density last year. All minerals usually have crystal shape. However, sometimes you can't see it without a microscope. Cleavage is how the mineral splits. Does it split easily along flat surfaces? How many flat surfaces does it have? Fracture is going to be how the mineral looks if it breaks apart instead of cleaving. And what special properties might that mineral have? Does it have fluorescence? Is it magnetic? Is it radioactive? Does it react with acid, or does it have electrical properties? So those are some things that we will be able to look at and identify different minerals. Let's start with mineral hardness. In 1812, the man on the left, named Friedrich Mohs, came up with a scale to identify how hard minerals were. He picked 10 minerals that would represent the hardness of varying different minerals, and you can actually use these minerals to try scratching other minerals and see if it can scratch another mineral, and then you can figure out where on the scale it is. He also figured out where on the scale some different items fit, like your fingernail or a copper coin or steel, so that you could use some of these common items to try to figure out how hard a mineral was as well if you didn't have any minerals with you. On the scale, the softest mineral is talc, and you'll see that up at the top of the scale, and it's considered to be a number 1 out of 10. It is the softest mineral that we have in the 3,000 minerals that exist in the world. Going up the scale then, he used gypsum for number 2, calcite for number 3, fluorite for number 4, apatite for number 5, 6 was feldspar, 7 is quartz, 8 was topaz, 9 is corundum, and 10 is diamond, the hardest mineral that there is. You cannot scratch diamond with any other mineral. The color of the mineral may not be the best way to identify it, but one way that color can help us is if we do something called streak. We use a piece of unglazed porcelain and we rub the mineral against it. And when that happens, we'll see the actual color of the inside of the mineral and not the outside. Now, in the picture here, you see that we've used 2 different minerals. One is a yellow mineral and it left a yellow streak. And one is a brownish, blackish colored mineral and it leaves a rusty reddish colored streak. So the top one is sulfur, which we can identify by its color, but also the streak is the same. The bottom one, while it looks very dark, it will always leave this brownish red streak, and that's hematite. Luster is the way a mineral reflects light. There are many different types of luster, but to save some time, we're going to just look at, does it have a metallic luster or is it non-metallic or dull? On the left side, you'll see a diagram that shows minerals that might have cleavage. Now, one that doesn't at the very top is quartz. You'll see on the right side is a piece of quartz that has this pattern and it looks a little bit circular up towards the top of it. That's called a conchoidal fracture. Quartz will just fracture. It doesn't break in any specific way. But some minerals will break with specific direction and it will make flat surfaces, and that's called cleavage. So if you can look at the other diagram on the left, cleavage in one direction will make nice flat sheets. An example of that might be muscovite or graphite. So it flakes apart with flat surfaces on one side. If you have cleavage in 2 directions, the example here being feldspar, you're going to have 2 flat surfaces on the side and maybe on the top. Some have cleavage in 3 directions. Halite is one of those. So you'll have flat on the side, both sides, and on the top and bottom, which makes cubic shaped crystals. And calcite actually has cleavage in 3 directions, but it's at a diagonal. So you'll have these diagonal shapes. Some minerals have properties that are particular to only one or a few types of minerals. Some of these might be fluorescence. For example, calcite and fluorite will glow under an ultraviolet light. So in the picture, you can see the same sample is shown in ultraviolet light in the top, and it looks blue, and in the bottom, it's mostly white with some purple. Some will have chemical reactions. If you drop a weak acid on calcite, it will bubble or fizz. Calcite also might have special optical properties. If you take a thin, clear piece of calcite and place it over an image, it will cause a double image. Some are magnetic. For example, magnetite and pyrite are natural magnets, and you can see they have some paper clips and bolts and things stuck to the magnet there. Halite is one that has taste as a special property. However, I would warn you, don't taste something unless you know what it is, because if you aren't sure what it is, you don't want to get sick. Some minerals will be radioactive, and so if you put them near a Geiger counter, it will go off showing that there's radioactivity there, like radium and uranium. Since we live in Pennsylvania, let's take a look at some of the more common minerals that we can find in Pennsylvania. Now, there's about 3,000 minerals worldwide. In Pennsylvania, we can find about 300, but some of them are pretty rare. There are about 60 that you could come across if you get lucky. Halite is one of the most common minerals in the world. You probably have some in your kitchen. You'll find it in the salt shaker because halite is just sodium chloride, which is table salt. Most of the time, we will find this as a white mineral with a vitreous luster. Remember that it is soluble in water. That means it can dissolve in water. It will have a salty taste, and usually you're going to have to mine it in Pennsylvania. There's large, deep deposits of halite in the northern and western areas of Pennsylvania. There are some rocks that may have halite in them. We would call those evaporites. And some sedimentary rocks in Pennsylvania may contain a cast of halite where the crystal existed, but over time it may have dissolved in water, and so it's no longer there. So the cast would remain behind, which would mean the shape Almost like if you've had braces and you got impressions. The impression that you have behind, that's a cast of your teeth. So you can find casts of salt crystals in some of the rocks here in Pennsylvania. Graphite's another very common mineral. Again, you probably have this in your home. You probably have it in your hand right now. The tip of your pencil is actually made of graphite. Graphite is usually black in color with a metallic to dull luster. Usually it's going to be very soft and it will mark paper, and that's because the structure of graphite is very weak bonded between the upper and bottom part. As you can see in the photograph on the upper left corner here, the structure is flat sheets, and so you can rub it against the paper and it will come off very easily and leave markings on your paper. Usually we find this in marble deposits that are available in southeastern Pennsylvania, so somewhere near the Philadelphia area. So it's a pretty common mineral and it can be found here in Pennsylvania. Another interesting mineral that we can find here in Pennsylvania is made of lead and sulfur, or lead sulfide. It's known as galena, and it is usually gray in color. It has a metallic luster, so you can see that it looks shiny like a metal. And it's usually pretty dense, meaning if you hold a small piece of it in your hand, it's going to feel very heavy. Like halite, it has cubic crystals, and you can see that in the picture here. We have mined this in Pennsylvania, usually in southeastern and central Pennsylvania. Also found here in Pennsylvania are chalcopyrite and pyrite. Now, pyrite's also known as fool's gold. That's the one that you'll see on the right here. Chalcopyrite also has a gold color, but you'll see it's a little bit more brassy in color, and pyrite's a little bit more pale. The difference between the two is that chalcopyrite has copper, so it's CuFeS2 for its chemical formula, and pyrite is just FeS2. Now, Fe stands for iron, and that's why we might find both of these in Pennsylvania near iron deposits. Chalcopyrite is the brassy yellow with metallic luster, and it can be found in southeastern Pennsylvania. Again, usually found by iron deposits. It can be found in small quantities in other parts of the state, but usually in southern Pennsylvania. The pyrite on the right is going to be the paler yellow with still a metallic luster, also known as fool's gold. There can be some small quantities found around the state in some sedimentary rocks, but again, usually it's going to be found near iron deposits, and that might be because, again, both of these have iron in them. The next minerals we're going to look at are magnetite and hematite, both which have been mined for their iron in Pennsylvania. In colonial times, we would find hematite being mined for the iron, but nowadays we would mine the magnetite. So you can see that they both have iron in their chemical formulas, magnetite being Fe3O4 and hematite being Fe2O3. Now, magnetite is black with a metallic luster. It's going to be attracted to magnets, and the biggest deposits here in Pennsylvania are in Lebanon and Berks counties. Again, we usually are going to be mining those for their iron. We also can find them in small quantities on the surface statewide. You could actually take a magnet into streams and pull up small pieces with a magnet. Hematite is usually going to be a reddish brown color. It can also be gray or black, so hematite's one that can be a little tricky because depending on how it's weathered, it can change its color. Using a streak, though, it will always have the reddish brown color for its streak. It can be found in sedimentary rocks statewide, and it's also thought to be what may make some sedimentary rocks in the state red from the Triassic period. Another mineral found here in Pennsylvania is calcite, or CaCO3. It can be different in appearance depending on where you find it. It can be colorless and transparent. It can be white or gray and be opaque. It can also be yellowish, either clear or opaque. It usually has a vitreous or glassy luster, and you can even find it as crystals in some places. Now, usually we're going to find this with limestone deposits in many of the areas of the state, calcite being the principal mineral that we find in limestone. Also, we find calcite in marble, and so we can find this in some areas where there's metamorphic rock in southeastern Pennsylvania. Another mineral that can be commonly found in most rocks in Pennsylvania is quartz. Its chemical formula is SiO2, and it is a silicate mineral, which is very common around the world. It is possible to find this as colorless and transparent, like the first picture here. However, there are many other varieties, like amethyst, which is the purple, the rose quartz, which is the pink, jasper, which is the red. Also, there's flint and chert, which many Native Americans would have used to make arrowheads and other tools. Quartz can even be found in its crystal states in numerous locations around Pennsylvania. Now, there's no way that I can go over every single mineral in Pennsylvania because, remember, there are 300 of them, some being rare. But some of the more common ones, or even some of the rare ones that you could find gold, which you could find panning in streams. It's not going to be a lot, and it's going to be teeny tiny flakes, barely visible. But there is some here in Pennsylvania. We do have some copper here that can be found in Adams County, Cumberland County, Franklin counties. It had been prospected in the past. There is sulfur here. You can find it in crystals, some places around the state, near coal mines especially. If you know where to go in Pennsylvania, you can find quite a bit of interesting minerals around the state. Don't forget that Pennsylvania also was partially covered by a glacier thousands of years ago, and those glaciers may have pushed some interesting materials down from the areas north of us, like Canada and New York State, and you could find some minerals that maybe aren't supposed to be in Pennsylvania, but got pushed here because of the glaciers. So if you know what you're doing and you know where to look, you can find some interesting minerals, and those minerals will combine to form some interesting rocks here in Pennsylvania. Happy mineral hunting, folks.